Good afternoon, folks. Welcome to Inventor 101. Last week, we were busy making this item here. This is a baseboard. So you have various options. If you're getting started with robotics, what you can do is you can acquire this part. This red board over here is, in fact, the main board from this robot. But before you build this out into a robot, what we can do is we can just get a hold of this board. In a previous video, we soldered on these header pins here. And then what we did is we put this Arduino Uno that has the long pins underneath it. And we put this on here like this. Is we can start programming on this Arduino Uno without the pins short-circuiting and getting damaged. We can also put a breadboard over here. What I wanted to do was just design something in Inventor 101 where we've got a bigger breadboard here. We've got the Arduino over there. We've got a little bit of press stick underneath here. Breadboard is actually permanently attached to this piece of plastic base with double-sided tape. So what we can do here, we can screw this thing in place, or we can just stick it down with a piece of press stick. So what we're going to do now is we're going to go to a shared screen. This is what we were busy with last week. Move that around a bit. So now hopefully you can see everything that's going on my screen. So if we go back to the very beginning, you'll see there's nothing there. So the first step was in fact to create this drawing. Step number one, we drew the sketch. We drew the blocks on the inside and the outside. The next step is we extruded the frame 5 millimeters. The next step was we extruded these inner pieces by 2 millimeters. So the main part of the frame is 5 millimeters high and the outer part. So the main part is 2 millimeters up, extruded up, and then the frame is 5 millimeters extruded up. The next step is basically to give it these rounded corners. So what's happening here is we do a right click on the sketch and we go to edit sketch. And then you'll see there's a fillet function over here, which is where we can basically, if we click over there and over here, so let's click on the fillet function and we click there and you'll see here it's filleting it, but we don't want it to be so dramatically filleted, so we can click on 5 millimeters and you'll see it gives it a less of a corner over there. So now we go around and we can click over here and it does the same over there, and we go over here and we go over there. So you need to click 2 lines on a square to get a filleted effect. When we click Finish Sketch, what you'll notice now is that this board that we made has got these filleted corners. Now, what we can also do is we can add an extra step here. So what that extra step is going to be is we can go here to Modify and we can go to Chamfer. And now, if we click on this line here, it will chamfer this by the amount that we dial in over there. So we probably don't want something as dramatic as a 3 millimeter chamfer. You can see that's quite dramatic if I zoom in there. So let's change this number to 2. You'll see it's still quite a strong chamfer there. But let's try, say, 1.4 millimeters. And that's a pretty good effect over there as far as our chamfer goes, so that's quite handsome. What we can also do is we can fillet, that's a fillet, or a chamfer is the square one. We can do the same effect on these lines here. So let's zoom in a little bit and let's do like so. So we click there and we click there and we click there and we click there. So those are the lines that we've included in the chamfer. We can do 2 mils, that's quite strong. So let's maybe do 1. And now, if we want to include these lines, you can hold the control key down. So if you hover there and you try and click there, it won't include that line because you've already put a value in over here. So if you hold the control key down and you click on that chamfer effect, you'll see that it's inactive. If you hold the control key down, it becomes activated or active. So now we've got our chamfers in place, and I think that chamfer is quite strong. So let's go down to 0.75. And okay, the reason for that is I just didn't want it to be making a complete V shape over there. So what we're doing now is we're zooming out and we're zooming around the place, and let's click on the little house button, and then let's zoom in a bit and have a bit of an inspection of this part. So basically, let's go to sharing, stop the sharing screen. So essentially, this is what we're doing. Now, let's go back to Fusion. And so inside of Fusion 360, there are various functions that we can use to get this onto a 3D printer. So basically, what I want to do now is I want to open up the bodies. So you'll see there it's called body 2. So this whole part here that's highlighted in blue now, you'll see it's gray. When I click there, it highlights that part, that's the body. And then if I click here, you'll see this is the sketch. So we can switch the sketches off and on over there, or here we can hide the sketches. So let's get rid of that. We can also hide the body in both places. But what we need to do now is we're going to do a right click on that body. And it says here, save as an STL file. What you'll notice here is it's now trying to save it as an STL file. So we can just have a look at this under our Save as STL options. You can see we can change this, but I'm going to leave it as a high-res file, and I'm going to go OK. What it does now is it opens a save dialog, and we can drag this over here, like so, to there. And now, under Models, so under my CAD CAM CNC, we've got models here. So I'm looking for a model Arduino baseboard. So there's an STL file there, but let's call this version 2. So rather than overwriting that one, I'll just call this version 2. So now we've saved this effectively as an STL or a 3D file. Now what we do is we're going to go over to a software called Cura. C-U-R-A. What you're looking at there is Ultimaker Cura. I'm just going to clear out that model out the way there. And Ultimaker Cura is called a slicer of software. So that's where you take a 3-dimensional STL file and you set it up to print on the 3D printer. The first thing you do really with Cura is to make sure that the Cura software needs to be set up for your particular type of 3D printer. So I'm just going to do that and pull it up to here so I can see from the top to the bottom of the screen. So you're looking at Ultimaker Cura now, and you'll see here it says prepare and preview and monitor. We are going to go to the prepare function. Over here you'll see we've selected a Creality CR20 printer. That's the particular type of printer that we're using. What we need to do is we need to bring that model in. So we go to wherever you've stored your files, we go here and we look for models, and we're looking for the Arduino baseboard model. And you'll see here, there it is. That's Arduino baseboard version 2. So we click on that and we open that, and it actually brought it in there. So what you'll see is there it is. That, folks, is our baseboard. It's a relatively simple design. It's a simple design. Smaller designs are ideal for newcomers. Something useful around the house or your workshop, I can recommend. And these are the different views, folks. So that is a front-on view. That's an overhead view. I'm using the middle wheel of my mouse to scroll around here. And that's an overhead view. This is a side view from the one side, side view from the other side. So you'll see that it says right view, left view, and this is an isometric view. So when we zoom in on this part, you can see the actual part itself in the preparation view. If we go to the preview view, then what you will see is over here, there's a button that says slice. And now this model has been sliced. In other words, it's been rearranged that the 3D printer can print it. And if we drag this down, you'll see layer by layer, because 3D printers work through deposition of a filament. You'll see this is 3 hours and 58 minutes to print. And over here, this is actually recording the different layers. So this is quite a thin model. It's only comprised of 17 layers. And if we go down to layer 1 and we hit this play button, you can literally watch how the 3D printer puts the filament down onto the bed. It's quite interesting to see how so if we go halfway, let's say we go down to layer number 5 and we press play over here, and we can zoom in and you can literally have a look at how the 3D printer creates your 3D model by clicking on the different layers. So let's go up here. So with this strongly zoomed in view, you can actually see, just by pulling around here, you can actually see how the 3D printer, so that's layer 17. So if we jump down, that's layer 15. And there's a bit of a hollow section over here. So what I'm going to do is I'm going to show you all, I'm going to walk you through the different functions of Cura, because there's a lot of different settings in Cura with regards to the heat, temperature, and speed of the 3D printer. So let's assume that everything here is fine and good. You can look at, this is what the model looks like finished, but in more detail, if you click on this preview view, that's your preparation view, and this is your slice preview view. And what you're seeing there on the screen is actually how the filament is laid down. It's melted. The 3D printer works through heat. It heats up the filament. It's almost like a very precise, very high precision hot glue gun. That's how it works essentially. And this is an overhead view where you can zoom in and you can look at the individual lines. But there you can see those little stripes and how it builds up this part layer by layer by layer. So it's fascinating. You can, even if you don't have a 3D printer, I would encourage you to get a subscription to Fusion 360. It's free, and download the Cura software and start slicing your model, start figuring it out. And let's go down halfway through the model. So here you'll see this. This is a hollow fill over here. So you can save on printing time and you can save on filament by going there. Now, these are your settings, print settings. There's a lot of settings here. We've zoomed in on our print settings on that side of the screen. I'm going to move this model a little bit that way. So hopefully we can see everything all at the same time. And now I'm going to find somewhere else to put this item over there. And let's go through these. So you've got headlines like quality, shell, infill, material, speed, travel, cooling, support, build plate adhesion, these, and then you've got some experimental settings. So these are the main headlines, and these are the main things that you have to consider when you are doing 3D printing. Quality relates to the thickness of the layers. So I'm just sticking with some of the presets that are acceptable for this printer, and I'd recommend you do the same. If you're unsure, stick with the default. So what have we got here? We've got layers of 0.28 millimeters. Now, if you want if you don't mind waiting a long time for this model to print, you could change that to 0.2 or 0.1 or 0.25. But for me, 0.28 is perfectly acceptable. So we stick with that. Your line width, that's to do with, and you'll see over here when I hover the mouse, it gives you these little dialog boxes which explains to you what these things mean. So rather than getting too bogged down in all of this, let's just accept that all of this is pretty good. And so let's go out of there and let's go here. So the next one is the shell. So if your model is hollowed out quite a lot, that means the inside parts of your model are going to print hollowed out, then your wall or your shell or your outer, so we've got wall thickness 0.8 millimeters, and that translates automatically to 4 layers for your wall line count. So your wall will consist of 4 layers of plastic. Then your top bottom thickness is 1.12 millimeters. Your top thickness is 1.12 millimeters. Your top layers is 4 layers. Your bottom thickness, your bottom layers. So for me, 4 layers forms quite a strong shell, and I generally stick with 4 layers. So that's entirely acceptable. If you don't understand what all these things are, you can sit here and read these dialog boxes, but we're not going to get too bogged down with all of this. Let's move on to the next item, which is your infill. So that's the hollowness of your model. Now what you'll see is if I normally print a model at 22% infill density, so the walls are 100%, they're solid, but the hollowed out shapes inside your model don't always need to be solid plastic. It takes a extra long time to print the model, and the model's heavier, and in fact not always necessarily stronger. So 22%, but let's increase this to say 55%. And now what you'll notice is that little dialog here, slice. Every time you change the settings on this side, you have to re-slice the model. So what you'll observe now is that if I change this here to say 88% full, and I re-slice the model, you'll see that instead of the model being largely hollowed out inside, it's actually almost solid. So you can see that effect there, where it's, and then obviously your bottom and top layers are solid. But if I change this back to say 11% over there, and I re-slice the model, you will notice that it's mostly hollowed out in these thicker sections. The thick sections are over there and over here, and it's hollowed out. So let's go back to 22% because that's a nice sort of value somewhere in the middle. And now let's have a look at the effect on printing time. So this model is going to take 4 hours, believe it or not, to print this little board. But that's because I don't like to print on a very high speed. You can speed up the printer, but then sometimes the quality of the printing goes down. So let's have a look at the effect of making this say 88% on the infill density. And if we slice that, now the model is 4 hours and 19 minutes. So it does take longer to print. So let's go back to 11% and see the effect on time there. These are estimations, so it's 3 hours, 54 minutes. So it's not this model doesn't have a lot of hollow parts, so it doesn't make a massive difference. But let's go and have a quick look at the effect of the line of the thickness. So the way you lay these down. So if we want a really finely printed model and we go down to 0.1 millimeters and we slice that, and now you should see it. So now the model is going to take 7 hours and 49 minutes to print. And for a model like this, you don't need very fine quality, and it's now gone up to 48 layers because each layer is so much thinner. So let's have a look at these thin layers. So you can see the 3D printer is going to put down very fine, very thin layers. So personally, I don't think that's necessary. We can go up to say 0.3 and we re-slice it. And let's have a look at the effect on time. So now it's more or less the same as what it was before, because before it was 0.28, and we slice that, and there we go. So it's slicing, and that's 3 hours, 58 minutes. And all these other numbers here are really fine tuning that you can spend a lifetime figuring out what effect they have. It's really a very practical exercise. There's no definitive answer to what might work on one model might not work so well on another model. Smaller models tend to print easier than larger models. Now, material-wise, this will determine your printing temperature. Now, the recommended printing temperature for PLA, that's polylactic acid, which is what I normally print most of my stuff in because it's just convenient. It's a very easy material to work with. It's not too temperature sensitive. So the recommended value here for printing temperature is 180 degrees. But I find that the environment here, these offices are a little bit cool with the air conditioning. So I find that if I dial up the printing temperature to say 2, so if we stick at about 212, somewhere around there, we get good results because that PLA is coming out of the extrusion nozzle at quite a high temperature. It's pretty molten. It very quickly cools down and forms onto the part, and you don't get, sometimes if you print with your nozzle temperature, your extruder temperature is too low, you get a stringy model that doesn't have any internal strength. The layers literally just break apart. What I've found with my particular type of PLA and the particular printer that we have here, that somewhere between 200 and 222 degrees Celsius is a good temperature to work with. If you're out there and you're an experienced 3D printing person, you might be critical of all of this. You'll also look at my build plate temperature. Now, we have a 3D printer with a heated build plate. I don't recommend buying a 3D printer if it doesn't have a heated plate because it's quite tricky. There's a lot of problems if you don't have a heated print bed. So the recommended temperature for the print bed is normally 60 degrees for PLA, but you'll notice here that I've got this thing dialed up to 76 degrees Celsius, which is pretty hot. If you wipe that print bed with a wet or damp cloth, it actually gives off steam. It's so hot, that print bed. But I don't use hairspray because if you spray on your print bed with hairspray, if you have a 3D printer with a BL touch sensor for setting the height and doing bed leveling, if you get hairspray into the BL touch sensor, it stops working, and they're like 500 odd rands to replace every time, and they're almost impossible to get working once they're gunged up. So I don't use tape, I don't use anything. I literally just print the PLA plastic onto a mirror these days. I get a beautiful mirror-like smooth, because this is literally printing onto the mirror. There's no glue, there's no Pritt glue, there's no hairspray, nothing, and it's literally got a mirror-like smooth finish. And it's really very nice because once the printer stops and cools down, this just pops off the print bed. You don't have to prise it off the machine and mess up the alignment of your 3D printer. 3D printing is all about fine tolerances and alignment. And if you watch the videos on YouTube, they're recommending that you use a paint scraper to prise your model off the print bed. It's all crazy. I don't recommend that at all. To get the model to stick to the mirror, I heat the mirror up so that the mirror is so hot that the PLA, polylactic acid, is a little bit soft, and it's grabby and it sticks to that mirror like crazy. If you try to pull it off the mirror, it doesn't really want to come off the mirror, but once the mirror cools off, the model literally just almost pops off the mirror. So that's something that took me a long time to discover, and a lot of frustration, a lot of hairspray and gunged up BL touch sensors and all sorts of things. If you're printing onto a mirror, somewhere between 75 and 80 degrees Celsius on your heated bed. If you don't have a heated bed on your 3D printer, you might want to consider upgrading to a 3D printer that does have a heated bed. Otherwise, you're going to be using blue painter's masking tape to print onto. That's your temperatures of your materials. I'm not going to talk about ABS and all sorts of other specialized materials. Before you've mastered PLA, I wouldn't even recommend that you try looking at other materials. Speed-wise, you can go with your defaults for your machine. This is, some people are printing at 100 millimeters per second and 80 millimeters per second. I would rather know that my model's going to come out right and everything's good. So we're just sticking with 44 millimeters per second here. Your wall speed's a little bit slower. So, you really can fine tune all of these settings. One thing I do is I normally slow down my travel speed slightly. The filament needs to be heated up to the correct temperature at the correct moment in the printing process. But it is equally important that the plastic, the molten plastic that's coming out of the extruder also needs to be rapidly cooled off. Otherwise, your model just turns into a lump, a blob of molten plastic. So the PLA must come out hot and it must quickly cool down to form a solid for the next layer to land onto. So stick with the defaults over here. Keep your fan speeds up at 100%. But later on, once you start to become more advanced, get onto YouTube, watch all the videos. There's literally hundreds of enthusiasts out there, some who know what they're talking about and some who don't, giving lots of good and bad advice. So check that out. Now, this one is quite important. This is called support. Now, under the headline support, if you click on that, it opens up a whole section. And usually I try, when I'm thinking my design through at the fusion stage, I'm already thinking in terms of what it is. Am I going to be printing the model on a 3D printer? That's the most important question. Are you going to make your model on a CNC machine? Because the approach to your design changes according to the destination or the machine that you're going to make your model with. So the moment I know I'm going to make something on a 3D printer, my entire design is designed around trying to make it optimal to print on a 3D printer. So try to avoid needing support, but if you do need support, then you need to click on this and you need to decide what type of support. So you're going to have support everywhere, or you're going to have just support where the model touches or is overhead of the build plate. So what this means is support everywhere means you might have a hole halfway up the wall of a little box that you're going to 3D print, but you actually need to print something in there so that the top section of the hole doesn't, because you can't really 3D print effectively in mid-air. So if you're going to have something up and going over, you need to have support everywhere. But if you don't have holes and strange features on your model that need support, then you might get away with just touching on the build plate. And then this is the pattern of your support pattern. You can choose from cross, gyroid, triangles, grid, and then you can actually determine the density of your support features. So more dense, in other words, thicker plastic with no neutral space, is going to slow down how long it takes for your model to print. So lots of fun, lots of videos on YouTube giving you good and bad advice about that. The next thing is called build plate adhesion. Now with the system I'm using now, in other words, I'm using a mirror that's very hot, which keeps the PLA sticky and sticks the model. The models are not being bumped off or knocked off or falling off or warping off of the print bed. So I'm generally printing with no build plate adhesion features. But what you can do is you can have a skirt. So let's reslice the model each time just to see how this changes things. So what you'll notice now is there's a few lines around your model. Now, a lot of people print a skirt like that just to let the 3D printer wipe its nozzle clean before starting work on the model, because once the 3D printer will only start printing when it reaches temperature, and then normally there's a blob of PLA that's come out of the extruder and it ends up in your model and it causes all sorts of troubles for you. So a skirt is a good idea, but it doesn't really help the adhesion qualities of the model. A brim, and I'm just going to reslice there, a brim is quite a useful thing, because what a brim does, you'll see the brim over there, and let's go to the top of the model like that, and so if you look at the model, the brim is not part of the model. So the model is there. If we preview the model, you'll see this brim appears. So what the brim does is it adds almost like an extra bit of plastic around the edge of the model that stops the model, because models tend to curl up as they cool off, as the different layers of plastic go on. The model cools off and it tends to curl up from the outer edges. This brim feature holds the model down and gives it extra stick. So sometimes, depending on the size, the bigger models I usually do a brim, the little ones I don't do a brim, because obviously if you use the brim, then when the model's finished printing, you have to cut the brim off, and that can be fiddly and time consuming. So now you can choose how many lines in your brim. So you can do 44 lines in your brim. If you're really worried that your model is going to pull off the print bed, you can do a very wide brim. So if I'm printing more than one copy of, say, a big little box to put electronics into, I might widen my brim because the first one that I printed curled up a little bit on the edges, and I just want more meat to stick the model down to that mirror. Obviously, it does increase the print time of the model, but not too dramatically. So 4 hours, 41 minutes. Let's take that down to probably 11 is probably a good compromise. So that's now 4 hours and 3 minutes. There's another option here, which is called a raft. And a raft is where you're having real problems with the model sticking to the build plate. So you actually print an entire raft down onto the build plate. And then the model is here. So if we have a look at this, there's the model. And then we go like that. So this raft, the only problem with the raft is now the model prints to the raft. And when you peel this model off the raft, then you have to sandpaper the other side of this item because it's got all these little points where your model printed on top of the raft. So it's easy enough to separate the model and the raft, but it does leave a few what's called artifacts behind, which can spoil the beautiful, clean look of your model. Then the next option here is none or nothing. So if we look at that, we reslice the model, and you'll see that the prepare view and the preview view of the model is exactly the same. Under experimental, there's some interesting things there. So these are all things that are completely beyond the scope of today's presentation. The final thing that you need to basically do is just, before you're going to print, just scroll this up and down, have a look at your model, make sure you're happy with what you're seeing. You can even just have a look. This is the last layer printing. And just have a look at the speed and the movement of the head, make sure that everything looks sensible. Once you're satisfied with everything, you can connect a 3D printer directly to your PC. You can network them and do all sorts of things, but most folks just put a little memory card into this little micro SD card slot. We put the micro SD card in the holder, and I've put the 3D printer on preheat mode so it can warm up so long. And now what I'm doing is I'm going to put this micro SD card here into this computer's micro SD card slot. Now you'll see this is flipped over. It says save to removable drive. So this software has detected that we've put a micro SD card in there, and it's as simple as just clicking on that. It's now copied it to the micro SD card. We can eject the card, and we could put this in the 3D printer and press go, and it should just print. So we're going to go back to the 3D printer, and we're going to start up the 3D printer. Now I've set it to the preheat PLA settings, which is a bit below my temperature settings, which are much higher. So it'll take a few moments to get going, but let's go check that out. The 3D printer is now starting the print job. First thing it does, it wipes a line down the edge there. You'll see it's printing onto a mirror, and then it goes to the middle. And so now what it's doing is it's basically printing out that shape. And yeah, it's going to put down the first layer. So I'm just going to take a stroll over there and check everything's going fine, but it looks all good so far. So it's put down some of those holes. So if there's little shapes within your shape, it'll put those down, and now it's putting the surround around it. And so it's going to carry on for quite some while until it's done. With a mirror printing method, you clean the mirror just with plain water on a little bit of tissue paper, and you keep that mirror spotlessly clean so that you don't get little bits of dust and stuff included into your print of your model. So I'd like to thank you all for attending today. If you're watching this video on the YouTube channel after the fact, you're welcome to join future Zoom sessions with us. Just go to robotscience.co.za, Robotics 101, for more information as to how you can join.